Okay. So first things first is this was a matrix. This is just a condensed form of writing a matrix. Okay. So notation. This means the sum of coefficients times x equals b. Does anyone know what that means if they want to draw it out or no? So when I'm saying sum of a of ij, these are subscripts. Okay? Subscripts basically are, let's say, like locators. Okay? So if we think of a grid, say Manhattan, that's a grid. We have East 11th Street and First Avenue. You know, we locate where things are. These are subscripts. They locate where we're going to put this. Okay? So if I'm saying, let's start from scratch. So if I'm saying A11 and A12 and A13, this makes a vector or a matrix of one column of A11, A12, and A13. Okay? So if I say this is equal to 1, this is equal to 0, and this is equal to 2, it's going to equal 1, 0, 2. So these over here tell me where I'm locating my constants, my coefficients. Okay? Does everyone get that? No? Yes? Okay. Consensus. Okay. Then I'll move on. No one said anything. So let's do a simple matrix. So, okay. Well, I'll show you with a simple matrix. It's called a 2 by 2 matrix. And if it's 2 by 2 because these are just points. There's something, 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 something. So there's one value, and one value, one value. So this is 1, 2. This is 2. This is 2. I wrote nothing in there. It's just, so this is a 2 by 2 matrix because there's 4 coefficients. Okay? So if I do, I have 1x plus 2y, and I'm not setting it equal to anything right now. And I have 0x plus 3y. In my matrix representation form, maybe I'll go to my previous lecture. So when we're setting up our matrix right now, I'm saying, what's A11? It's this value. This is my A11. What's A12? It's this one, yes. A12. If we want to read how this really says, it's row 1, column 2. Okay? So these are rows going this way, and columns are going this way. So it's row 1, column 2. Okay? So, yes? Those are variables. Those are your variables. Right now, when I'm saying we're setting up our coefficient matrix, we use the constants. We use the A11 or the A12, the coefficients, whatever is in front of the variable. Okay? So basically, this is what I had in the other lecture. It's the same thing as saying that, just a shorthand, a condensed way. So say if we had j equals to 1. It's the summation of j equals from j1 to n. And let's say I equals to 1. And we have n to the third. So I have the summation of j equals to 1 to n to the third. N equals 3. If we were to write that out just with the a's and the a's and the x's, putting no numbers in for a. And I say I equals to 2. So if we write that out, we have A21 x1 plus A22 x2 plus A23 x3. So my I equals to 2 is saying that I have row 2. Because these are the rows. And my J is my columns. So if we were to do this for all I's, this is for one row. So this is a row, row 2. Alright? If I had I equals to 1, I would have this. And there's values here. In this case, there's only 3 values. So. And say if I have I to the m, we have m amount of rows. Okay, so matrices is like a grid. You're locating where things are. And in the worksheet number 2, I think most people saw how to plug in the coefficient matrix once I wrote out all the formulas or all the equations. And basically I'm just taking these here and leaving out the x's. So it's like if I have x plus y and x minus y. When I say x, obviously there's a 1 in front of it, because 1 times something is something. So when I write my coefficient matrix, this is just going to be 1, 1, 1, minus 1, because of the minus sign. Okay? So that's your coefficient matrix. And your row echelon form. Does anyone remember what that is? Okay, so it's we use linear operations of the rows to get it into a nicer form. Because say if we had, now this is just for a coefficient matrix. We have 100, 99, 2, 7, 2, 1. That's 2, 1, 1, 3, 2. This looks horrible. It's hard. It's difficult to work with. So what we do is we try basically to put in a systematic form to make it easier to work with. So that's what row echelon is saying. So an example of row echelon is 1, 2, 3, 0, 0, 0, 1, 2, and 0, 0, 0, 0. So what we want is the leading, this one, to have some values and anything below it not to be 0. Sorry. The topmost left should have a value, and everything below it should be 0. Okay? So this is called leading. This is a leading 1. So here in this case, this is a leading 1. Is this in row echelon? It is, because everything below it is 0. Okay? But if we had a 1, 2, and 1, 0. Now this is the leading 0. Okay? This is not 0, therefore it's not in a row echelon form.
How do you know which is the leading?
Okay, the leading the leading number has to be, we had made some definitions, I wrote the definition out, but basically what it has to do is the row above it, so if this is your leading 0, right? Everything to the left is 0, and everything to the bottom is 0 in that case. And so if we look at it from the top, this is your leading 0. Everything below has to be leading 0. So this 1 has to be 1 down and to the right of it.